In this video, we will look at derivatives of trigonometric functions. In particular, I will discuss in detail the derivative of sine of x and the derivative of tan of x. I will also tell you about the derivatives of the other trigonometric functions like cosine, cotangent, secant, cosecant, etc. But I do sine and tan in detail, and then the other ones are a little bit similar. So if you understand these two cases, you will understand all of them as well. So here I plotted the sine function, sine of x, and I'm interested in the derivative sine prime. Now we have learned that sine prime is in fact the slope, right? The derivative is the slope of the tangent line which is sitting on the curve. So what I like to do is to start with a function and kind of guess how the derivative will look like by looking at the slope of this function. So let's start with some specific features of the sine function. For example, here the slope is 0, and this is exactly the value pi over 2. So then at this value the derivative is 0, meaning the slope is 0, so I indicate it here. Okay, at this point, same. So then here it is 0 again, so this corresponds to this value, and then we get another 0 here, and we can do it in the other direction as well. We get a 0 here, and a 0 here, and a 0 here. So these are all the slopes, the points where the slope of the function is 0. Let's look at the 0 of the sine function at 0, so here, and here the slope is actually 1. So here the slope is equal to 1, so I make a point here. At this point it is the opposite slope, so the slope is actually minus 1, which will then be here, and then slope is 1 in this case, slope is minus 1 over here, and this oscillates also plus and minus 1. Now let's try to guess how this function might actually look like if I connect those points. Well, I get an oscillation similar to before of that sort. Now, can we guess what this function is? I can. It looks heavily like a cosine function. So, is this indeed a cosine function? Let's compute this. Now, to compute the derivative sine x prime, I need to borrow some earlier results. So I borrow from the study of limits that the limit as h goes to 0, sine h divided by h is equal to 1, and the limit at h goes to 0 of cos h minus 1 divided by h is equal to 0. These limits are discussed in the textbook or in the homework assignments, and we will need them here. And the other one is an addition formula for the sine. Sine of x plus h is sine x cos h plus sine h cos x. And then we can start to compute. So if f of x is sine x, then f prime of x is of course the limit as h goes to 0, f of x plus h minus f of x divided by h. Usual thing. So then this is equal to the limit of sine of x plus h minus sine of x divided by h. Now for the sine of x plus h, I use the addition formula which I just mentioned before. So then this equals the limit as h goes to 0. Now sine of x plus h is sine x cos h plus sine h cos x, and then minus sine x, which is still there, and then all this divided by h. Now I can factor out common factors and write these terms in a more convenient way. And I combine the two terms which have a sine x. So I write this as limit as h goes to 0, and I factor out a sine x, and what I keep is a cosine h minus 1 divided by h, okay? And then plus a cosine of x, sine h divided by h. So now this might seem a little bit fast, so if you think this is too fast, then please stop the video and do it yourself. But now I can use a property of the limits, so that the limit of a product is the product of the limits. So then I have limit as h goes to 0 of sine x times limit as h goes to 0 of cosine of h minus 1 divided by h, and then plus the limit as h goes to 0 cosine x times the limit as h goes to 0 sine h divided by h. Now the limit of the sine of x does not actually depend on h. Okay, so this is just sine x. Sine x. Then the limit h to 0 cosine h minus 1 over h is right up here. This is equal to 0. So we get times 0. And then this term is cosine x. And this term is equal to 1 from the property above. So taking all this together, we find that sine x prime is actually cosine. Yippee! And this was our guess. It is indeed cosine of x. Now similarly we can compute the derivative of cosine, which is minus sine. So here it's important that we have another minus sign. So sine prime is cos, but cos prime is minus sine. Let's compute the derivative of tan x. So how would we do this? So tan x prime, of course this is sine divided by cosine of x prime. And then we have a rule which we can use. Yes, the quotient rule. Low d high minus high d low, draw a line and square below. So let's do this. Low is cos, d high, so high is a sine, and the derivative of a sine is another cosine. Minus high d low, high is sine, and the derivative of cosine is minus sine. So we get this. Draw a line and square below. And of course we square the denominator. So, fantastic. So then this is cos square of x plus sine square of x divided by cos of x squared. Okay, and cos square plus sine square is equal to 1. Okay, so we get 1 divided by cosine squared, which I also can write in this form. But 1 over cosine is a secant, so then this is the secant squared of x. So the derivative of tan is actually secant square. So that's it. And then here I show you all of them. So we have seen those two, and these are super important. Derivative of sine is cos, derivative of cos is minus sine. And then we have the other four, so the derivative of tangent is secant square, derivative of cotangents is minus cosecant square, the derivative of secant is secant times tan, and the derivative of cosecant is minus cosecant times tan. Okay, so you definitely should remember the first two. If you remember all 6, that would be even better, of course. Oh, hey Marlo, that's quite impressive how you are juggling all these trigonometric functions. You must be really good at those. Oops, boink, boink. It's so hard.